I'm Adam Pritchard, and this is Pastime. "47 million years ago, there was a lush, tropical jungle in what is now southeastern Germany. I wouldn't recommend that as a place for a tropical vacation. Nowadays, it's not there anymore. But the organisms that lived in that jungle left their remains in a remarkable fossil site called the Messel Pit. Now, Messel is actually a site that's so amazing that we dedicated a whole episode of Pastime to it several years ago. It's a great example of a Lagerstätte deposit. Now, Lagerstätten are fossil deposits that preserve fossil organisms in exceptional ways. At Messel, you get complete and articulated, fitted together skeletons of animals ranging in size from 8 or 9 foot crocodiles down to tiny mouse-sized rodents, bats, lizards, and even insects. But it's not just the skeletons. At Messel, you also have lots of soft tissue preservation. You get impressions of feathers, scales, fur. And so we get this amazing picture of what these organisms looked like in life that we wouldn't get from an unusual fossil deposit. Now, Matt actually visited Messel several years ago to examine a creodont called Lesmizodon. So this is a little weasel-sized carnivorous mammal from 47 million years ago. And he was very pleased to tell me, the reptile expert, that one of the specimens of Lesmizodon still had its last dinner in its belly. And that was a tiny lizard. And we didn't really talk too much about that specific fossil in the Messel episode because there were so many other ones to discuss. But a fossil like that Lesmizodon is actually a truly incredible thing because it preserves direct evidence of a trophic interaction. Now, trophic interactions occur when organisms consume energy from other organisms. This can take the form of an herbivore eating a plant, a parasite attaching itself to a host, or a predator hunting down its prey. All of these are examples of trophic interactions, and they're really easy to see in the modern world. But in fossil ecosystems, we have to make hypotheses about trophic interactions because it's very rare that we get direct evidence. But the discovery I'm talking about today is even more amazing than that. From the journal Paleobiodiversity and Paleoenvironments, fossil snake preserving 3 trophic levels and evidence for an ontogenetic dietary shift. Now, this new paper by Drs. Krister Smith and Augustin Scanfurla describes an absolutely beautiful specimen of a snake from the Messel Pit site. The snake belongs to the genus Paleopython, which, rather confusingly, is actually most closely related to modern boa constrictors, an anaconda. And inside the belly of that Paleopython is its last meal, a complete skeleton of a basilisk lizard called Geisel-Talielis. And inside of Geisel-Talielis' stomach, there are the remains of a tiny insect. So not only do we have the last meal of the snake, but we have the last meal of the last meal of the snake. This is only the second reported example of this kind of two-step trophic interaction being preserved in the fossil record. The previous example was over 300 million years old, a specimen of a shark that contained the skeletons of 2 amphibians, and one of those amphibians had eaten a fish. To find these kinds of specimens requires exceptional high-quality preservation where you get most or all of the skeletons of the animals involved. And also, we have to catch the predators before they've had time to fully digest their prey. Based on modern snakes, Paleopython could probably have digested Geisel-Talielis completely away within 3 or 4 days. If the snake had died a few days later, we would have no idea what its last meal was. And Dr. Smith and Scanfurla were actually able to learn a lot about the biology of these animals, not just that they ate one another. This example of Paleopython is about 1 meter long. That's just over 3 feet. And that's not at all the biggest example of this species. Paleopython can grow almost twice that size. So this is a relatively young animal. The specimen of Geisel-Talielis, the lizard, is pretty close to the average adult size. This specimen adds some very interesting details to our understanding of the diet of Geisel-Talielis overall. It's actually the most common lizard species from Messel. And previous examples have been found with plant material in their stomachs, seeds, and the remains of leaves. So to find one with an insect in his stomach suggests that Geisseltalielis had a varied diet that included both plant material and animal material at different times. And that's very similar to modern basilisk lizards. They're omnivorous. They eat both plants and animals. It's also interesting to find a snake similar to a boa that ate a basilisk lizard in this ancient tropical jungle. There are examples today of boa'd snakes living in the same places as basilisk lizards, and there they have been found to prey upon those lizards. It's not clear exactly how common it is, but it's interesting that this ancient relationship between these two species, Paleopython and Geisseltalielis, is something that we still see in their very distant modern cousins. Exceptional fossils like this are very important. We can make a lot of very good hypotheses about how ancient organisms interacted because we can compare them to modern organisms. But it's a fossil like this that contains incontrovertible evidence of behaviors that indicates just how confident we can be in making those comparisons. And that's how this incredible specimen helps us reconstruct a past time.